All right, so this would be section 8, writing linear equations with 2 points. So to write a linear equation, we need to address and find the vertical change between the 2 points. Step 2, we would need to find the horizontal change between the 2 points. In step 3, we will divide the vertical change by the horizontal change, or you are finding rise divided by run. And so in our equation, those 3 steps help us calculate our slope or our unit rate. So using the unit rate or the slope that we just calculated in steps 1 through 3, we need to go backwards to find the starting point or the y-intercept. Once we have those 2 pieces of information, we'll be able to write our equation. Now that we've went through a couple of context problems, we'd like to go ahead and formalize the slope equation. Or the slope formula. So I want you to think to yourself for about 90 seconds. If you had 2 generic ordered pairs, x sub 1 comma y sub 1 and x sub 2 minus comma y sub 2, what would the equation look like? So I'd like you to write in this space here the mathematics of steps 1, 2, and 3 using these 2 ordered pairs. See what you can come up with. So step 1, find the vertical change. Step 2, find the horizontal change. So these could be any numbers. You can maybe think back to the activity we just did. What did you do with those numbers? All right, let's go ahead and look at what this might look like. So step 1 is to find that vertical change. And so if you're thinking about these ordered pairs being on a graph, the vertical change would come from the y values. And if I was going to subtract, I'm going to go ahead and write y sub 2 minus y sub 1 just because 2 is bigger than 1, but you could write these in any order. But if I'm finding the change, I would need to subtract, just like we did with our context problems. Step 2 is to find the horizontal change. However, we already know that we're going to divide those two changes. And again, our horizontal change would be the change between the x values in the ordered pairs. And if we're going to write this as a formula, we'd want this to be equal to something. And slope, we know, can be referenced as m in our y equals mx plus b format. So we're going to write m equals. And so maybe in the past you've seen this written down as the formula for slope, and maybe in 7th and 8th grade you were shown y2 minus y1, x2 minus x1 being divided. However, this equation can sometimes be written incorrectly by students. Because ordered pairs are written x comma y, a lot of students will put the x's in the numerator instead of the y's. And so make sure that we are able to come up with this equation so that you can write it the correct way. Okay? So let's go ahead and keep this in your background here. We'll use the slope equation here as we work forward through our lessons. So in context here, we have example number 1. The Jones family has 51 gallons of water on day 2, 27 gallons of water on day 5. Write an equation for the situation. So the first thing you might want to do is go ahead and write this information as 2 ordered pairs so that we know which goes with which. So on day 2, we have 51 gallons of water. And on day 5, we have 27 gallons of water. And so if we want to write an equation for this situation, we first need to calculate the unit rate or the slope. And with those 3 steps, we said we were going to take the vertical change, horizontal change, and we're going to divide them. I'm going to share a way that you might consider finding the unit rate. And you can write your ordered pairs as a table to find the unit rate. So I would know that 2 was an input, 51 was the output, 5 was the input, 27 was my output. And the reason why a lot of students prefer this method is because now for sure I'm going to subtract my y's and subtract my x's. So the change from 51 to 27, subtracting those, and I'm going to subtract down. 51 minus 27 is a positive 24. And now my change 2 to 5. So I subtract down on the y's and I subtract down on the x's. 2 minus 5 is negative 3. And so now change in y divided by the change in x. So I'm progressing through my table at what rate? 8 gallons, right? Or I have a unit rate of negative 8. So 8 gallons per day, my unit rate is negative. So another benefit of the table here, guys and gals, is that you are only 2 days away from the starting point. So I could say day 1, day 0. So you can have some context here. Working backwards, going from 51 back to day 1, does that value need to be bigger or smaller than 51 if I'm using water? Bigger. I'm going to go up. So I know that I could add 8 one time to go up my table, and I could add 8 again to find my partner with 0. And I know when I find that partner with 0, I found my starting point. And so if I add 8 twice up the table, I would have a partner of 67. However, this problem is nice because we're only 2 days away. However, what if I don't want a table a mile long if I have data for day 300? So a shortcut mathematically, where am I? Okay, so I'm at 51, and I know that I'm using water, so I need to be bigger. How many days away am I? 2, and I'm changing at 8. So you could use that mathematics of where I'm at, moving up the table, 2 days away at a rate of 8. That would be a second option. And I'm going to show you guys as the honors class what a third option and utilizing our equation. So option 1 was the table, option 2 is the mathematical approach, option 3, let's use y equals mx plus b. So we found our m, which is negative 8. B is the starting point that we want to find, and we were given 2 ordered pairs. So I would, it doesn't matter which ordered pair you use, I'm just going to use this first one here. My y value is 51. So 51 equals, m is negative 8 that we calculated, my times my x value from the ordered pair is 2 plus b. So now, negative 8 times positive 2 is negative 16. And add my 16 over to get b by itself. I know my starting point is 67. So all 3 of these methods, table method, just the nuts and bolts of working backwards from the table, or using y equals mx plus b to find our starting point, they would all yield the same final equation for this situation, which would be y equals negative 8x plus 67. Okay. So on this next example, we're going to go ahead and we don't have any context. We're just going to go ahead and use the third method that I just shared with you. So first of all, number 1, I'd like you to take 30 seconds here and calculate the slope. Calculating the slope, you can plug into the table method, or you could use the equation that we wrote down as m equals y minus y divided by x minus x. So on the table method here, I'd have 2 minus 17, negative 15, 4 minus 9, negative 5, change in y divided by change in x, rise over run, if you think about that creating a table. Same over here, 2 minus 17, 4 minus 9, negative 15 divided by negative 5. So either way here, my slope is 3. And so now we're going to use y equals mx plus b to get our starting point. So I know my m is 3. I'm going to use the first ordered pair listed here. Again, you can use either ordered pair, it doesn't matter. But make sure you take the 2 and plug in for the y. So you're getting the ordered pair x, comma y. Make sure you plug it into the right spot. So 2 equals 3 times 4 plus b. And again, we're using this to calculate that starting point, working backwards. So 3 times 4 is 12. Subtract 12 from both sides. Now my starting point is a negative value. And if you go back and look at your table, that would make sense. As I'm working up, my input of 4 was 2. I need values that are smaller than 2. Eventually I would be in the negatives there. So my final equation would be y equals 3x minus 10. Or if you're in that habit, you could write y equals negative 10 plus 3x. Okay? So this is formalizing how to find that starting point, giving you 3 different options. So we're going to, that concludes section 8 notes.